Is ETT similar to crystal growth waterproofing product? No, it's not. It's enzyme based. The enzymes react with the free calcium, builds a gel in the subsurface of the concrete very fast, so it has the ability to thermodynamically crack seal future cracks that forms. Existing cracks up to 2 millimeters. Crystal growth can only seal up to 0.4 millimeters. Crystal growth needs 35 to 42 days to grow to build the crystal in the constant presence of water to be able to do so. The enzymes have the ability to crack seal existing cracks up to 2 millimeters and future cracks up to 1.5 millimeters within the thermodynamics and immediately doing the process of the crack forming. Crystal growth is too slow. 0.4 millimeters a hairline crack. Anything and anybody knows concrete cracks more than 0.4 millimeters. And most importantly, anything above grade or above ground is thermodynamically exposed. Crystal growth cannot take thermodynamics. The enzyme-based waterproofing technology of our chemical has the ability to crack seal future cracks and thermodynamically, and has the ability to do this very fast compared to the crystal growth system. Can TEQ 2500 waterproofing agent be applied over an area where a crystalline growth waterproofing product was previously used? Crystal growth inside the concrete is perfect. We also provide a crystal growth product. The technology of crystal growth inside the concrete and enzymatic TEQ technology works in harmony to each other. It improves the performance of the ETT inside the concrete if crystal growth is present. Is the ETT suitable for waterproofing precast panels and precast elements? Yes, we are perfect for the application of these kinds of precast segments on panels. What needs to be looked into is, of course, off-form release agents and surface preparations and cleaning so that our water-based ETT get absorbed into the surface of the concrete. And detailed work for the joints of the tilt-ups, precast panels and everything else need to be addressed with the system that we provide in the project that these precast panels and segments are supposed to be installed in. Therefore, each individual precast situation needs to be addressed in the system. Please reach out to the technical boys to see what we're gonna do with each and individual item that is in the precast realm of things. Short answer to the long story, yes, precast is perfect for us. You need to be careful when you're installing the ETT products because we do add glass and aluminium protection we needed for those glazed areas and glass areas. Is ETT suitable for waterproof of all types of concrete? The principle in concrete is strength. So we work from, 2,500 PSI, 20 MPa, towards 65 MPa, 9,500 PSI. If the concrete is too ultra high performance and it doesn't absorb water, we don't get driven in. If the concrete as a backbone is not strong enough, the ETT builds a membrane inside the concrete. The concrete is your backbone. The backbone is the one which holds the membrane in place and as in integrity waterproof the concrete. If your concrete is too weak, institute screeds below 20 MPa, not enough PSI and not enough thickness. We need at least 3.5 inch of thickness or 75 mm, 100 millimeters of thickness, because if the thickness is too thin, it's not enforced, the strength is not there, the backbone is weak, therefore the membrane will be weak too because the carrier is the concrete, right? So the concrete needs to be in that bandwidth of strength. Fly ash discussions, please reach out to the technical department on this one. But in principle, we say as long as you are below 20% fly ash, we don't have so much of a problem. If it goes above that, you do need to accelerate the next day the surfaces. And if it goes way above a certain percentage points, then it's not a suitable part to us. The grade of fly ash and the type of fly ash needs to be highlighted to us. Cement replacements, in generally, I would rather ask you guys to reach out to the technical department on special cases. But golden rule is you stay below 20% cement replacement, you will be fine. How deep does ETT waterproofing penetrate into the concrete? 20 millimeters, 2 fingers as a minimum depth into concrete. That does not mean that we build a uniform layer. wherever the imperfections, cracks, fissures and openings of the concretes are, the gel forming will depenetrate in and forms the gel in the matrix of the concrete continuously. So you will have an uneven membrane penetration, because wherever the concrete is very porous, needs to absorb more water, has more openings and fissures, where more calciums are coming out, more gel forming and more membrane building is. Can coatings and or paints be applied in areas treated by ETT? We do not interfere with any intercoat bonding adhesion to any kind of material which comes after our waterproofing has been applied inside the concrete. We don't bead shine, we don't make any debonding layer. It doesn't matter if it's hot melts, hot applied, cold applied, cementitious based products, coating systems. We do not interfere with any intercoat bonding adhesion to anything which goes after us onto the concrete. Treated ETT treated concrete and not ETT treated concrete looks the same. It behaves the same. If you're based on a cementitious based product, I mean your tile adhesives, your grouts, your plasters, renderers, anything that goes cementitious based onto the surface helps us, because inside the cementitious based products we have calcium. The calcium bleeds into the concrete which is treated with ETT. That is very good to build a bridging layer between the two, between the ETT treated concrete and the cementitious products which goes on top of them. So it's helpful with ETT treated concrete to have more bonding with cementitious products on top. Non-cementitious product, we don't interfere with any bonding whatsoever. How well does ETT prevent foreign materials such as fuel, oil, grease from penetrating into the concrete? And do these materials adversely affect ETT's performance? Once the membrane has formed in the subsurface of the concrete is protected from all ingress of all harmful materials, down to oil and grease and hydraulic fluids and all kinds of many different chemicals and water and any other areas for that matter. So oil and contaminants will superficially lay on the surface, which gives us a natural look of the concrete, but it can be easily removed by water jetting, cleaning and removing with high pressure washing of the surface. It will not deep penetrate inside the concrete matrix, and it will not deeply the problem is oil and grease and anything else that goes inside the concrete very often is deep penetrating and deep sitting inside the concrete, and therefore very difficult to remove. The ETT has to be applied early in the process into the concrete, prevent any kind of contaminants, oil and grease or anything else for that matter, to have a deep hold inside the concrete. Superficial, super layers, easy to remove with water jetting, no deep penetration, no deep defect, no deep contaminations of the concrete or the concrete members or anything else that affects the structure or the enforcement or anything else in that concrete. So, short story answer is, it's superficially layers on the surface. It will not deep penetrate any contaminants and oils in the surface, and is easy to maintain and cleaned. Is ETT waterproofing agent UV stable? We do not build foam or film. We don't shine, we don't bead, we don't build anything as a film thickness on surface. We inside the physical matrix of the concrete. Treated and untreated area are the same. Therefore, we have no UV degradation because we are inside the concrete. If the concrete breaks down, we will break down. If the concrete fails, we will fail. As long as the concrete structurally holds, we will there for the lifetime of the concrete. There is no UV stability necessary because we don't build a film, liquid or sheet or anything else on the surface of the concrete. What effects do high and low temperature have on the ETT waterproofing performance and resealing capabilities? The application temperature, since it's water-based, cannot be too cold or not too high. It has to be above freezing in Fahrenheit and Celsius, and it has to be below the temperature of cooking an egg. Basically above 100 degrees Fahrenheit or in my 40s, 50s degrees in Celsius. If that happens, on the high end temperature, you can then bring water first down to make evaporation on the surface. So you spray water down, the water just disappears. You can apply the ETT, and then you water it after 1 hour. If it's in freezing temperature, you need to be in a 24-hour cycle above freezing. More details on the temperature ranges, please refer back to our technical data sheet, which gives specific temperatures for application rates. Is ETT environmentally friendly? Yes, of course. We are totally green. You can literally drink us in principle. So we have NF61, we are VOC free, we are completely, you can spray us into rivers and greenery. We are completely in green product, and that's one of the main sales argument for our product, because we are not building any kind of harmful layers on film that needs to be disposed of, no chemical waste. We are integral to the concrete, and we are protein based. We are an enzyme protein based product inside the concrete. Has absolutely zero environmental impact on anything, because we are inside the physical concrete. We are not we don't need to be maintained. You don't need to reapply. We are there for the lifetime of the structure. Therefore, also no reapplication that is necessary in the environmentally framework of a repetitive installation that you do with any kind of other membrane. We are not related to the oil industry. So any other liquid, hot applied, cold applied, sheet or liquid applied system, all are maintenance items which need to be replaced, removed, and are then special waste. They are not to be able to be put into the normal house waste, house trash. They have to be special waste, has to be disposed of in a particular matter which is environmentally damaging and which is also expensive. We are, as I said, completely protein based inside the concrete. No impact on the environment during application, no PPE, no in confined spaces, in tanks, in water retaining structures. You do not need to wear PPE, you don't need to protect. We have no problem with the impact to into the environment with discharge of water. You don't have to trap it back, you don't have to hold it back. We have no impact when we are doing the application that somebody has to wear a big mask and PPE systems and extractor fans and fuming or anything else. There is no any environmental impact during the application, during the lifespan of the product, in the concrete, and afterwards. Basically, this is a completely VOC-free, water-based, enzymatic product which has absolutely no impact during the application and also in the process of the building itself. There is no bleeding or evaporating into the building process of harmful ingredients that goes and deeps into the building. There's no such thing. What precautions should be taken if ATT is being sprayed in an enclosed, confined space such as water tanks? And that's the beauty where we shine. Confined spaces doesn't need extra PPEs. We don't need to protect the application from fumes and gases that conventional systems have. Of course, confined spaces are OSHA requirement regulation. So you need to, of course, look at the normal construction practices of airing and oxygen levels in confined spaces, in big tanks. But beside the OSHA requirements that is required for the general safe application of workmen inside a water retaining structure, we do not need any necessarily additional protection in terms of mask, PPEs for protecting from the actual application of the material. We are completely VOC free, we are completely fume free, gas free or anything free in that regards. So we do not bring an unnecessarily additional step of protection that you need when you apply ETT in confined spaces. Furthermore, the speed of application by application of the ETT and the watering 1 to 3 hours later, and then the detail work gives you the opportunity to work in water tanks and confined spaces in a much faster and much more successful way than if any conventional system. What level of head pressure will ETT handle prior to failure? Once the gel has formed, after a few days, it can handle up to 1,300 feet, 400 meter or 529 psi of head pressure. What happens if hot asphalt is applied over concrete surfaces that have been treated with the ETT? We are very good in that concept because hot asphalts with 380 degrees Fahrenheit, 200 degrees Celsius, give or take, will not melt the concrete. If the concrete melts itself and fails, we will fail. But we will not fail before the concrete fails. If the membrane has formed inside the subsurface of the concrete, after a couple of days, hot asphalt will not melt the surface. Furthermore, you can shot blast, scarify the surface without removing the waterproofing. That means you can mill, reapply, resurface asphalts on surface of concrete, and you will not damaging the waterproofing membrane by temperature or physical means, except you are more destructive, that you are going more in than an inch of the concrete.